Hi, this is group number 10. Our scene design project is about design epoxy potting of caps for capillary filtration. This project is specifically about capillary filtrations because the capillaries are small to filter water. A major part of this model is cap epoxy to stabilize the bundle of capillaries. The goal for this project is to simulate the temperature profile in the reactor cap as a function of curing time and analyze the temperature profile under different parameters. Water is an absolute necessity of life. However, human beings have very limited access to fresh water on the earth due to increased population, climate change, and rapid pollution growth. The demand for water filtration has been high throughout human history. Therefore, we need water filtration device.
Our design approaches are modeling and simulation. First, we choose a proper kinetics module to describe epoxy reaction and try to calculate the heat release from the reaction. And then use those knowledges to simulate the in-console. We mainly focus on Camille's module. Use Camille's module, we can have a better understanding of the design. On the right is the 3D module we generate in console. By assigning different materials properties in different domains, we can regenerate the hollow fiber bundle into console. In console, we can do lots of cool things. By inputting the Camille's equation, we can even generate a realistic simulation. It is shown on the right. We can see that epoxy is generating heat to the capillary, and with the time, when the curing finishes, it won't generate heat anymore. By using console, we can have opportunities to see the actual process before we make it into the real world. In console, we have multiple parameters to change. By adjusting those parameters, we will get different temperature profile, and use those temperature profile, we can analyze more in detail. Therefore, we can generate a best solution into the process line. Our group have three parameters to modify and analyze the relationship between the amount of epoxy and the heating curve. This is the first parameter. We focused on the relationship between the number of capillaries and the amount of epoxy. As we can see from the graph, as the number of capillary decrease, the maximum temperature increase about 40 Kelvin.
The second parameter is wall thickness of capillaries. As we can see from the figures, when the wall thickness increases, the maximum temperature of each wall thickness will decrease, and the curing time will increase.
The third parameter is the thickness of epoxy. The graphs below are the temperature profile of the epoxy pottings with different thickness of epoxy. The temperatures start increasing along the time and start decreasing when the reaction is ended. From our simulation, it has been proved that as the thickness of epoxy increases, the temperature will also increase.
For safety considerations, we need to know physical and chemical properties of materials that we use. We need to also avoid exposure to high concentrations of epoxy resin. Breathing highly concentrated epoxy vapor can irritate the respiratory system and cause sensitization. When we inhale these dust particles, they become trapped in the mucous lining of our respiratory system, so we need to be careful when we're handling those chemicals. For acid considerations, we pay a lot of attention about the environmental impact of our project. In fact, most of the resin is not biodegradable and the process of recycling them is complex. This means that traditional resins could last in the environment forever, leaching chemicals and releasing carbon dioxide daily for hundreds of years. To burn the epoxy resin, it will release carbon dioxide, which will cause global warming. So in our design, we prefer to use biodegradable epoxy. For economic considerations, if we put our design into industrial production, here is an estimated cost of our material and labor. During the competition of our nowadays market, our product have the greatest advantage that we choose to use biodegradable epoxy, which means it has less harm to both human and environment. Although the price of our product may be a little higher than others, we believe that people value their own health more than price. This is our senior design video. Thank you.